welcome back to your channel. So in this session we're gonna discuss about the main important topic. Before that, you have to know the answer about this question. Why you don't float away into space? Is this question anyone can answer this question? Your answer can be read in the comment box. So let me answer this. Why we don't float away into space? Just you gonna in Earth. We are all living in a Earth. Why do we don't float like on the moon, whereas astronauts float there? Why? It is due to the main and important topic, gravity. Gravity difference is the main thing to be float away and not float away into space. So let's get deep into this topic. Just you know that. Yeah. Another question, how the moon stays in its orbit around the earth. So our all of us know that in space means in moon also we float, but in space we are all float, but how moon will be in an orbit? Not only moon, all planets also, of course. They do there in their orbits. Just gonna be a centripetal force, which is our gravitational force. Just like, what is a centripetal force? Centripetal force. And another force. So let's go to the following topic, gravitation. You carefully look at this. Yeah. Here a ball is going down. Why it is happening? Due to gravity. The apple is going down. Why it is happening? It is due to gravity. Means due to gravity or gravitational force, we can, or all objects, of course, they go downwards only because due to gravity. So let's get into what is gravity. Just know this. What is gravitation? Any attraction force between two objects. Any attraction force between two objects, we call it as gravitation, which is denoted by F. And then it says, yeah, F. Okay, we can also, yeah, you know the story, which is a concept. It's a good story, you know that. Okay, let's get. Gravitation may be the attraction of the objects by the earth. Here it is the gravitation definition, which is said that gravitation may be the same attraction for objects by earth. You know that. For example, if a body is dropped from the certain height, it falls downwards due to gravitation. Hey guys, you see this picture? You know that? It's apple tree. Here Newton was sitting. Who was sitting? Newton, Sir Isaac Newton. He was a great scientist who introduced three laws on motion and the concept gravitation also. Okay, we can let's see. Gravitation may be the attraction. Means, why to an apple fall downwards only? Why it gone to float away into the space? Why it is happen? This is the attraction force between two objects, apple and earth. And nextly example. This is the example. Apple is dropped from a certain height from the tree to downwards. So this is due to gravity, guys. So gravitation may be the attraction between objects in our outer space also. So here it is a earth and it is a moon. So what this statement say that gravitation may be the attraction between objects in the outer space also. You can go to the outer space. There's maybe attraction force, which is the gravitation force also, but it's going to be centripetal force also. Okay, attraction between the earth and the moon, which is example for this. Example, attraction between sun and another planets also. Okay, let's go to, this is the concept, guys. We have to centripetal force. What is centripetal force? Before I say that, which is the attraction force between planets or in a circular path or orbital path, in a circular path like this circular path, which is the centripetal force act here. Centripetal force act here. When a body moves in a circular path, this is important, guys. Important circular path. it changes its direction at every point. If you go on this circular path, it changes in second. Every point it changes the direction. The force which keeps the body in a circular path that acts towards the center of the circle is centripetal force. Hey guys, you know this? The force which keeps the body in a circular path means this is the center. It keeps the body in circular path. Okay? Nextly, and acts towards the center. What that force acts towards the center? That force acts towards the center. That force acts toward the center. FC, centripetal force. And circle is called centripetal force. Centripetal force means FC. You know this? Okay. Let's go to the next topic, guys. Yeah, every point in the universe attract every other object with force F, which is proportional to the product of their masses. This concept is called gravitation. Universal gravitation law means, I think, universal law of gravitation. We call it as universal law of gravitation. Just get it out. What we call it as universal law of gravitation. We're going to move this topic very deeply, guys. Let's get it now. So we all know that there is a universal law of gravitation. What is here? It is m1 means mass 1, m2 means mass 2, means f means gravitational force. We know that gravitation here I taking gonna space. You see that which is the gravitational force is there, guys. It is directly proportional to the masses of two objects, m1 m2. Masses of two objects means the attraction takes place between two objects. So I take mass 1 and mass 2. Mass 2 will be the earth, of course, many times. Mass 1 be the mass of any object. It is a concept here explained. And go on to the next topic, guys. Here taken, yeah, of course. And here distance is there between two of them. A distance is there. Then that distance is there. What we know actually if equal to m1 m2 because they are directly proportional. And here we going to know that t is inversely proportional. T is inversely proportional to the gravitation. T is inversely proportional to the gravitation. So let it be by t. By t, we add it by t. Okay. And then here by d square. By distance square, not only d here. By distance square. Oh my god, I can write t. Not t. D, guys. D. Distance square we have here. Okay, guys. Let's go on to be the topic here. And here F means gravitational force is inversely proportional to the distance square. What is the distance between two masses? Is the distance square. This is the formula derivation, guys. And here new thing we got in the formula is gravitational constant. It is a constant value of gravitation, which is gravitational constant which is equal to 6.673 into 10 power of minus 11 Newton meter square kg square. Keep it in mind, guys. Keep it in mind. Okay. Then what is our final value of the formula is F. What happened to this? Yeah. F equal to G into M1 M2 G M1 M2 by D square. This is the lastly formula, guys. This is the topic of important universal law of gravitation. Universal law of gravitation. That universal law of gravitation successfully explained and several phenomena which were believed to be unconnected. The force that binds us to the earth and the motion of the moon around the earth, the motion of planets around the sun, that is due to these are the applications of gravitational universal law of gravitation. These are applications. Keep it a note. These applications also most important. Keep it right in your notes. how these box I can draw here. These was very important applications of gravitational force. So you can pass and write, pause the video and write. Okay, let's go on to the next topic, guys. Here, Earth, Moon. What we show in the picture, Earth, Moon, and gravity. Gravity acts towards the moon, and gravity acts towards the Earth in opposite direction. In different directions, they show that. And the moon speed means it is the orbiter around the Earth. We know that it is the orbital. Here, this orbit, the moon revolve around the Earth. It is a natural only satellite of the Earth, and no gravitation and gravity. Okay, you know that what is gravity, what is gravitation, what is gravity, what is gravitation, what is the difference between two things. It's most important, and this is confusing topic also, guys. Many of them show us what is mean by gravitation and what is meant by gravity. Let's go a bit deeper in this topic, guys. We know that what is gravity and what is gravitation force. Here, gravitation is the force of attraction. Here, gravitation is the force of attraction acting between any two bodies of the universe. We can take any two bodies of the universe, which is the attraction force in between them. We call it as gravity. Important, guys, important. And gravity is the Earth's gravitational pull on the body lying on near the surface of the Earth. Simple difference, guys. Gravitation force means any attraction force between two any object, but gravity is the gravitation force, gravitation pull given by the Earth. It's called gravity. Here you show in the pictures any two objects which is attraction force is called gravitation, and gravitational pull of is gravitation pull by Earth is called gravity. Let's go to now free fall and acceleration due to gravity. Here, acceleration due to gravity, we call it as small g. Free fall means the object which is attract or go down, it fall. If I take an apple, in apple from the tree, it going to be down, means it fall down. It go towards the earth because due to gravity, we all know that. But here, it had some acceleration to came down, came towards the earth. This concept we all know that. But here, acceleration means the apple fall down in that time, it had some acceleration, which is equal to the acceleration due to gravity. Means due to gravity, the acceleration is constant anywhere on the earth, which we called it by small g. The small g value always equals to 9.8 meter per second or 9.776 something. That value is there, I can show here. Wait a minute. Then here, what is free fall means, anywhere it may be, it approximate to 9.8. Here, what is mean by free fall, guys? If an object is fell down, it has some air resistance. Means due to air resistance also, its acceleration due to gravity is changing. Anywhere on the earth, the gravitational pull which takes the acceleration which takes due to gravity is small g. Means anywhere the value is same, but going to the air resistance means the air which is present in the earth or atmosphere, the earth which opposes that object to come down, so that air resistance can change the acceleration, so the acceleration due to gravity also changes. So free fall, where free fall we call that the object which fell down due to gravity only, no any air resistance acting on it, and no any air resistance acting on it. So this is the concept of free fall, guys, and acceleration due to gravity. We know that formula F is equals to ma. I don't know. Firstly, we know what is the force. Here, force in ma. Force equals to mass into acceleration. We all know that force formula. Here, force formula included in gravitational formula equal to force equal to gravitational formula. Means, wait a minute. Yeah, gravitation, which is a force equal to gravitation. So hmm, here we know that actual formula, F equal to m1 m2 g by d square. Here this F is modified with ma equal to, then mass cancel, a equal to m by mass cancel, what happened, gm by, so here we take a earth, or it like earth shape guys. It had some radius, this radius equal to the, which is the object fall down, so we call distance as r square, radius square. So this is the actual lastly formula we got, and equal to g, this is also equal to g guys. Acceleration, here we modified this acceleration as acceleration due to gravity, which is small g, equal to gm by r square, the new calculation of acceleration due to gravity. So this is the center, this is the radius, this radius square means object here, apple falling to the center only, not only this side or this side, so we can take that area radius as maximum and minimum value. This is a calculation of gm square. Yeah, like a free fall of motion, or a free fall of motion, we know that when an object falls under gravity, it's in a free fall with constant acceleration. So we apply equations of motion, on that. So we know that v is equal to u plus at is equal to u2 plus 1 by 2 at square, v square minus v square equal to u square plus 2s. We substitute the values of you like distance means s equal to h, height, and here acceleration means small g, acceleration due to gravity. So substitute that values here. H equals to ut plus 1 by 2 gt square. And next formula, v equals to u plus gt, v, v square equals to u square plus 2gh. This like guys, this like, you have to, we can move this formulas into this. Here given this v square is equal to u square plus 2s, here v square is u plus equal to u square equals to 2gh, so that like change it, this like change it, this like change, we do with this. Nextly, the biggest topic, mass and weight. What is the difference between mass and weight? Actually, mass of an object is the measure of its inertia. It is a matter present, it remains the same everywhere in the universe. What is mass represented by kg? We all know that unit of mass is that. And in simple words, you know that mass means the weight of its atoms present in it. The weight of atoms present in it. It constant everywhere. But going to the weight, which is a force. Weight means force. We know that weight means gravitation force. So just like a gravitation force, it is a force. According to places, according to earth, it can be changed, and according to moon, it can be changed. Due to places, it can be changed. The SI unit is Newton because it is a force. The unit is Newton. So this is the difference between mass and weight, guys. So here you can clearly, mass is 50 kg here, 50 kg here, 50 kg here. Due to planets, it is a earth, it is a mars, it is moon. Due to planets, it not changed. We are going to the weight 490 Newton, here 185 Newton, here 80 Newton. According to planets or places, the weight be changed. So thrust, the force acting towards the center perpendicularly, we call it as thrust. The normal force acting on a surface due to the weight of an object placed on the surface is called thrust. This is also definition correct. The SI unit of thrust is Newton because it is a force. Going to pressure, it is the force per unit area. Means for a per unit area, pressure is thrust by area or force by area. Also we call it as. SI unit is 1 pascal. 1 pascal equal to Newton. 1 pascal equal to Newton per meter square. It is a pascal value. So here you create a triangle for better for formulas. Pressure equals to force by area, or thrust by area. We all know that. Area equals to, we going to substitute pressure here and area here. So the formula changed into like this: area equals to force by pressure. This is a triangle method of forming a formula into three different ways, which we have three quantities, and force equals to pressure into area. Here pressure, here divided, it goes to into, here into, it goes to divided. That's like pressure in fluids. Fluids also some pressure is acted. Fluids exert some pressure on the base walls of a container. You know that fluids exert pressure in all directions. It is the law of gravitation. Means not law of gravitation, law of pressure in fluids also. And pressure exerted on fluids is transmitted equally in all directions. And it pressure which is the acted on the base of the container. You know that buoyancy force. If you got some object which you fell into the water, it going to up. Why it is happening? Some force is acting on it to go upwards. It pushing upwards an object to float. That force is called buoyancy. And we here know Archimedes principle also. Here buoyant force, gravity force, and gravity force. This object is pushing down. It is going to up. This object different. This object different. This object different. This object different. This is iron going to be different, because we know that by this conclusion of these three containers and three objects, we know that buoyant force acts on their objects due to their masses or due to their weights, and it's just like decided by a object. It decided by a object. So the last and foremost a beautiful topical Archimedes principle. Take an object. I will take a woodcock like this only. I take woodcock. This here container, woodcock. This box, woodcock. I keep it in water. It can't be flowed. Why it is happening? The upward pushing force, which we called it as buoyancy force. But here I take a full container of water, not just like this, not just like this. I take a full container of water, just like this. I take full container of water. It's going to be filled with water. Okay, then I gonna put a woodcock here. I gonna woodcock. Okay, sometimes you know that I can take a woodcock here and keep it down. So here the woodcock, it is fully, before I take it put in a water, I fill it with full glass water or glass of full water. Then I keep it that woodcock. It had some space. It occupies some space. It also occupies same space in water also. The water displaced by it means water fell by it, fell by it, fell by it. The water which fell by it means the water fell by it. I can take this measure to calculate that woodcock value. To calculate that woodcock value. This explication is used in designing ships and submarines, locometers to find purity of milk, and hydrometer to determine density of liquid. This is the application of Archimedes principle, guys. Okay, guys, and this over. All of finished means my topics also finished. So, guys, if you like this video, subscribe to Harshit Academy, which all-rounder teaching classes, better and teaching classes. Many classes are available in our channel. In future we're gonna upload more videos for infinity learning, guys. Smart learning and infinity learning, you can learn anything here. So like, share this video to everyone, subscribe to our channel. Bye, guys. And more important chapter nextly, work and energy. Bye, guys. See in work energy. See in the chapter work and energy.